Go through Lico 3042, count prefix and suffix pairs. Give us a string array words, and you say that there is need to implement is prefix and suffix. If it is true that if string one is both prefix and suffix of string two, and it let us to find how many pairs. The things that the pair have the number index that have I smaller than j. So we'll say in this one has I equals to 0, j equals to 1. That is a pair because A is both the prefix and suffix of ABA. But since that if we have a solution, for example, a word ABA and A, we'll say this I is not a suffix of J. And also, we cannot say J is not a suffix of I because we need the index I smaller than J. So that means the order matters. So this goes also get our problem easier because we can just insert those kind of word in the index order. And then we insert the next word. We just check in our data structure with the next word, for example, word two is the whether we already insert, right? Whether we have some of the words inserted is a prefix and a suffix of word two, right? So, so the things that we don't need to check twice. What kind of data structure we can use? We can use some kind of chart structure, right? If we use chart structure to check prefix, it's kind of simple. And also, if we just only check a suffix, it's also simple, right? Just reverse. We insert those kind of words or bywords into the chart tree. And then when you insert the next one, possibly every time we insert for this node, we update accounts. When we next time we insert this word, we add those kind of on its path, we add every counts, right? Which is a prefix of this to the result. But it need to ask both prefix and suffix. So what we need to do is that possibly because the when we insert we 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 need both suffix and prefix. And we'll say this word, no matter whether it is from the forward direction or reversed direction, right? They have the same length. That means we can have a character, for example, character 0 and character n minus l minus 1, right? Assume this is length l. And C1, C l minus 2, right? This we can put some into some as a pair, right? So if we put the character in the front and then in the end into a pair, and then the second one and then next to the end as a pair, right? So we instead create the child tree into 26 children as characters. We just use a map, right? Map to compose. For example, this is an A, and then the end is a B, right? We can use a string to do this as a map key. But the thing is that we can also put this one as integer. Let the front one to be the index of this character, the left shift 5 positions, and add with all those kind of end character, right? And doing like this, actually, we have also two options. One is we have, because this one is just 26, right? Left shift 5 and or some maximal 26. We'll say that is 32 for the upper bound, 32 upper bound, right? So that is 10 to the power, so 2 to the power 10th range should be enough, right? So we can have a tri-nodes array of 1024, right? But that means that this will waste a lot of space. So that means that we use map, right? We map key is this kind of integer. Just have this index left shift 5 and all the n index. So after this analysis, we just write code. We can have class node, and we need for every channel we need a count, right? Because we want to count add when we insert our word on its path. If we see a count, we need to add to a result. And also, let's have a map. The key will use integer, and the value will be channeled as children. So this one will be new hash map. So we are going to create a char node root equals new char node. Um, and we need a result of 0. And we can for every word, right? String word in words, we can change this one as an array equals word to char array. And let's have its length in n equals array dot length. So what we do is that let's have a current, right? Current node, current equals root. So what we do is that um, let's use L as its length. Okay. So what we do is that for int I equals 0, I smaller than L, I plus plus. So we are going to have the key, right? Key. The left side character will be array I minus A, right? And we let's left shift this to 5 digits. And what's the right? That's all the right side. Right side will be array L minus I minus 1 minus A, right? So we will put this one as key. So let's say if children contains key, that contains key, if this children contains key, okay, right? If it doesn't, then we're going to have new uh channel, right? So we're going to children put a new channel. In that case, we'll move to the next. So we're going to have current equals current children get key, right? And every time we move, right, we need to add those kind of counts. So we'll have result should add equal to current dot count. And when we finished our current nodes, right? We also need to update current dot count should increase. In the end, we just return results. Python code is very similar. So let's um, create a class, right? Child class, child class for the child node. And for this class, we need a div uh, RNRT, and we need self, right? So this is a constructor. So self.children, let's have this as a map, and self dot count equals 0, right? So let's have result and root. Result equals 0, root as no. So for every word in words, the so we're going to have L equals length of word. Then what we do is that we'll have current equals root. For I in range um, L, what we do is that mm, we're going to have key, right? Key equals have this ordinary order S I word I minus order A, and let this one left shift 5, and we need on the right side as L minus I minus 1, right? So let's say if key not in current but children, then we'll have current dot children um key equals create a new one, right? Nodes, and we'll set current equals the current dot children key, and then we'll have result should add equal to current dot count. Um, and after we go finish this to the leave the last node, we have current count the plus equal to 1, right? And in the end, we just return result. Supported form key equals s word 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 I minus support operator. Do we have a lecture this one with this and I should have this parentheses here. And We should have one more instance here. Not key, not in current the children has no children. Child nodes has no attribute. Okay. So doing like this, if there are n words, and for every word it have an average length to be L, right? Then the time complexity is n multiplied by L, and the space, right? Because we the worst case that is every character, um, we need or every node, uh, every node, right? We need to have a separate channel to store, right? It's also NL.